So I wanted to do some examples of using the point-slope form for a line. Here's my first. Write a point-slope equation of the line with slope 1/5 and that passes through this point, -1,7. I don't need to draw pictures for all these. This is the most straightforward one. Recall that point-slope form is y minus y0 equals m times x minus x0, where m is the slope of the line, x0, y0 is a point we know to be on the line, and then x, y remain as variables. In your final answer, they will still be there as variables in the equation. So this is the most straightforward sort of problem we could ask about point-slope equation. We are told the slope is 1/5. We are told this point is on the line. So we simply need to plug in 1/5 and these coordinates for x0, y0, and we're done. We'll get y minus, and then y sub 0 is 7. That's the y coordinate here. Let me write these here as reminders. This is going to be x0, y0. This is going to be m. Then we have m, which is 1/5. Then we have x minus, and we have x minus -1, but I never write minus -1 because it's awkward and ugly. You seldom see that. Instead, I write minus the negative as plus. And there's my answer. The great utility of point-slope form is that if we were to do y equals mx plus b slope-intercept, we would have to do some extra work to figure out the y-intercept since we weren't told it. We'd have to plug in the point that we know and solve for b, and it's just a little bit more work. Now this form has a lot going for it. It's simple, it's already solved for y, but the main utility of this form is that given a point, given slope, you can immediately write down the equation without having to do extra work. Let's look at another example. I want to keep that one visible though. Write a point-slope equation of the line that passes through -2, 4 and 6, 10. So this is a lot like this previous one. Here I was told the slope and a point. Now I'm not told the slope. I'm instead told 2 points. Now anytime you want to write an equation for a line, in almost any circumstance you're going to want the slope. So my first step here is I'm going to determine the slope. So remember that slope is change in y over change in x, and we get these changes by subtracting coordinates. When I subtract here, I have to subtract in the same order. So I'm going to just go left to right on both of these. So my change in y is going to be 4 minus 10, subtracting the y coordinates. My change in x is going to be -2 minus 6, subtracting the x coordinates. And notice I did it in the same order. That's very important. 4 minus 10 is -6. -2 minus 6 is -8. So this reduces to 3/4. So there's the slope of the line that passes through these 2 points. Now, this is a lot like the previous one. All I need to do now is write down the equation of the line. And I have 2 points to choose from, so I could choose either one as my x0, y0. If I choose this pair as my x0, y0, then I get y minus 4, there it is, y minus 4 equals the slope, 3/4, m is 3/4, then x minus -2, which I'll write as x plus 2. Or I could choose this point, and I would get y minus 10 equals 3/4 x minus 6. Either one of these is a correct answer for a point-slope equation. This is another small drawback of the point-slope equation. It's a drawback and it's a plus, is that it's not unique. There's many different ways to write an equation of a line in point-slope form. Let's do a third example. Sketch the line with this equation. Y plus 3 equals 1/3 x minus 4. So one thing that I'd like you to be able to do is to see an equation like this and recognize it as point-slope form. So let me write point-slope form above this. It's y minus y0 equals mx minus x0. So in order to sketch this line, I first need to have a point that I know is on the line, and then I can use the slope to create changes from that point to generate more points on the line so I can draw the line. Now, the biggest frustration with working with point slope are these minus signs. It's a very useful form, but these minuses are frustrating because that means that when we go from the equation to the points, we always having this sign change we have to worry about. Take a look here. The equation has x minus 4, so that means x sub 0 is 4 if I just match these up. And here I've got y plus 3, but I've got y minus y0 in the forms. That means y0 has to be negative 3. This plus is concealing minus and negative. So you can see the equation has x minus 4, y plus 3, but the point has the opposite signs for its coordinates than we see in the equation. And that's a consequence of these minuses in the form that you have to always be on top of. So this point 4 minus 3 is a point that we know is on the line. And now I can use the slope to find extra points on the line that then I can draw the line. So the slope is change in y for change in x. Here that's 1 over 3. I'll treat these both as being positive. So this is up 1, change in y is plus 1, and right 3, change in x is plus 3. Up 1, right 3. Those are both positive changes. So that means to get additional points on this line, I can go up 1, right 3. I can repeat that over and over again in either direction. And the line must pass through all these points. So there is the point that I knew was on the line, and here are more points that I generate using the slope and the changes that the slope implies. Let's do an example with a parallel line and an example with a perpendicular line. Determine an equation of the line that passes through negative 1, 7, and that is parallel to this line. Y plus 4 equals negative 2/5 x minus 1. So in another place we've discussed parallel lines have equal slope. So I need to figure out the slope of this line that's given, and the line that I want that's parallel to it will have the same slope as this. And this again is testing to see, do you recognize point slope form? This is in point slope form. Y minus y0 equals m x minus x0. And all I really care about for this line is its slope. I can see the slope right here is negative 2/5. So my line also has slope negative 2/5. And since I know this point is on the line, I can immediately take point slope form and write down my line. Y minus 7 equals negative 2/5 x minus negative 1. So I'll write that as x plus 1. And there it is. It's got the same slope as this line, but it goes through this point, negative 1, 7 instead. One last using perpendiculars. Determine an equation of the line that passes through negative 4, 2, and that is perpendicular to the line with this equation, 4x minus 2y equals 14. So let me remind you, perpendicular lines have negative reciprocal slopes. So like that would be like 2/5 and -5/2. I'm not going to explain why that is the case in this video. This is something that we've seen elsewhere, and I'm just going to put it to use. So what this tells me is I need the slope of this line here, the line that passes through -4, 2, and that's perpendicular to this, which means I need to figure out the slope of this line first. Now this line, unfortunately, is not in point slope form, nor is it in slope intercept form. Y equals mx plus b would be slope intercept form. So this line is not in a good form for reading the slope off of it. So a standard technique, if I'm given a line that's not in a, and I want to know its slope, it's not in this form, I'm just going to rewrite it in this form by solving for y. So I'm going to move everything away from the y until I have y equals mx plus b. Then I can read the slope off the line. So first I'm going to subtract 4x from both sides. The plus 4x term on this side became a minus 4x term. Then I'm going to divide every term by -2. So this is -7, and here I have -4x divided by -2. The negatives divide away, and then 4 divided by 2 is 2. So I end up with plus, because the negatives divide away, 2x. And this is in slope-intercept form. I've got the x term written second. If that's bothersome, we can rewrite it like that. But the advantage of this now is now I can look at this line, this equation, and spot the slope sitting right here. But remember, the line that I want is perpendicular to this line. So this is not the slope of my line. Instead, my line's slope is the negative reciprocal of this, which means I need to get the perpendicular slope. I'm going to use my little perpendicular symbol here. So I need to take the reciprocal of 2, which is 1/2, and I also need to make it negative. So this is the slope of my line. So thus, an equation is, and I'm going to use point slope again. Here's the point that I know is on the line. Y minus y0, so y plus 2, equals -1/2 x minus x0, that's -4, so plus 4. And there we go.